MCA Prep Day 5. Our first benchmark today is 8244. Use linear inequalities to represent relationships in various contexts. Problem number 1, George worked 8 hours at his part-time job yesterday. Let W represent his hourly wage. Part A, write an inequality that shows that he earned less than $125 yesterday. So the important information here, George worked 8 hours at his part-time job. W represents his hourly wage, and he earned less than $125. So 8 hours times his hourly wage is less than $125. That would be my inequality. Part B, write an inequality that shows he earned at least $75. So he's still working 8 hours. His hourly wage is still W. If he earned at least $75, that means he earned $75 or more. So my symbol needs to be greater than or equal to 75. And both of these said to write the inequality. They did not say to solve it. Remember, when you're solving inequalities, if you multiply or divide by a negative number, it flips your inequality symbol the other way. So multiply, divide by a negative number. You have to remember to flip your symbol. And it doesn't matter if it's got an equal underneath it or not. Flip your symbol. Our next benchmark is 8245. Solve linear inequalities using properties of inequalities. Graph the solutions on a number line. All right, so my inequality to solve, the first step I'm going to need to do is distribute the -4. -4 times 3 is -12, and -4 times 2x is -8x. So here's my inequality. Now I can combine my like terms. I'm going to put a 1 in front, and my like terms are 1x and -8x. 1x combined with -8x will be -7x. My next step, I need to add 12 on each side. So then I have -7x is less than 21. And then I divide by -7. And like I mentioned on the last benchmark, dividing by a negative flips your inequality symbol. 21 divided by -7 is -3. So x is greater than -3. On my number line, I will use an open circle on -3, because remember that these inequality symbols are open, and when there's a line underneath, those are closed. And because this is a greater than symbol, x is greater than -3, you see that it matches the ray going to the right. So greater than, the numbers are greater to the right. So x is greater than -3 is an open circle with the ray going to the right. My next benchmark, 8246, says represent relationships in various contexts with equations and inequalities involving the absolute value of a linear expression. Solve such equations and inequalities and graph the solutions on a number line. Part A, number 1, write an absolute value inequality that represents all values more than 2 units away from 5. All right, so absolute value inequality says more than 2 units away. So that means greater than 2 units away. more than 2 units away. Now, it's the distance away from 5. To find the distance between two things, you subtract them. So in my absolute value bars, I need x minus 5. The distance away from 5, more than 2, is more than 2. Now, I want to remind you that the word goal is what kind of helps me remember what we're doing as far as our absolute value inequalities go when we solve them. So the greater than symbols represent the word or as connecting your compound inequality, and the less than symbols are represented with the word and connecting them. So remember the word or is a union, so it's when you put together two sets and everything counts, and is an intersection, like when you have to be both of those things. So those are very different things. Intersection is like a Venn diagram where you only have the piece in the middle. Union is your Venn diagram where everything would be included, like not just where they overlap, but everything is included like that. So not just this little piece in the middle, like on an intersection. Okay, so to graph the solution, we need to solve it. So this is a greater than symbol. So this means that my connecting word is or. So my first inequality is x minus 5 is greater than 2. My second one, I have to flip and change. Flip the symbol and change the 2 to a negative. I'm never changing the x minus 5 that's in the absolute value bars. That part stays the same. Now I solve these by adding 5 on each one of them. So x is greater than 7 or x is less than 3. So on my number line, the first ray, x is greater than 7, is open and greater than goes to the right. The second one, x is less than 3, is open and less than goes to the left. So it should make sense when you think about it. Our distance away from 5 is greater than 2. So greater than 2 units away from 5. If I went 2 this way, greater than 2 away, or 2 this way, greater than 2 away. Our next benchmarks, they're two combined, 8, 2, 4, 7, represent relationships in various contexts using systems of linear equations. Solve systems of linear equations in two ways, symbolically, graphically, and numerically. Oh, in two variables. So two variables, symbolically, graphically, and numerically. And then 8248, understand that a system of linear equations may have no solution, may have one solution, or an infinite number of solutions. Relate the number of solutions to pairs of lines that are intersecting. So intersecting lines, I'm going to underline that one in green because intersecting has one solution. Parallel is going to be blue because parallel is no solution. And then identical is red because that's an infinite number of solutions. So that's something that you need to remember, how those are related, that there's 3 different situations that can happen. The rest of the benchmark says check whether a pair of numbers satisfies a system of 2 linear equations and 2 unknowns by substituting the numbers in both equations. So substituting the values. So number 1 says consider the following 3 lines. Part A says which 2 lines are parallel. So I want to remind you that parallel means that they have the same slope, but different y-intercepts. So we need to figure that out for these lines. Which of them have the same slope but different y-intercepts? So number 2, this one we're done with because this one's in slope-intercept form, so we don't need to worry about this one. It's the first and the last. number 1 and number 3 that we need to rewrite. So I'm going to rewrite number 1, 4x plus 3y minus 6 equals 0. I'm going to put it in slope-intercept form. So the 4x is on the wrong side, and so is the 6. So at the same time, I'm going to just move them both over. So, cancel. So 3y equals negative 4x plus 6. And then if I divide by 3, I get y equals negative 4/3 x plus 2. So far, line number 1 and line number 2 definitely do not have the same slope. So now let's check line number 3. 4x plus 2y minus 8 equals 2. So I'm going to rewrite this one. On the wrong side, I have the 4x, so I subtract it, and the 8, so I add it. So I add the 8, and I subtract the 4x. Cancel. 2y equals. I need the negative 4x first, because slope-intercept form, you have the term with the x right after the equal sign. Then the 8 and 2 can be combined to give me 10, and that's on the intercept part. Divide everything by 2, and y equals negative 2x plus 5. So now I can tell that the ones that have the same slope but a different y-intercept are this one, line 3, and this one, line 2. So lines 2 and 3 are parallel. Okay. Now, for part B, we have to figure out which lines intersect at 3, negative 2. So that means substituting 3 for x and negative 2 for y has to be true in your equations. So I'm going to plug that ordered pair in each of the equations from the very beginning. So first of all, line number 1, and we're going to figure out if it's true. So if I put 3 where the x is and negative 2 where the y is this a true equation? 4 times 3 is 12. 3 times negative 2 is negative 6. 12 minus 6 minus 6, does that equal 0? 12 minus 6 is 6. 6 minus 6 equals 0. Yes. So this is going to be one of them. Okay, second line, y equals negative 2x plus 4. Where the y is, I put negative 2. Where the x is, I put 3, like this. Negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. So this one is also true. If I check line number 3, I'm going to use my rewritten equation for this one. So I plug in negative 2 for y, 3 for x. I check to see if this one's true. Negative 2 times 3 is negative 6, plus 5 is negative 1. That is not equal to negative 2. So the two lines that intersect at that ordered pair are lines 1 and 2. So you're just plugging in that ordered pair to make sure that it is a solution. And that is our last benchmark for today.